So, hi guys, my name is Stephanie. I'm one of the librarians here at the Barry J. Marshall Library. So here at this library, we support the students and staff in the science and engineering and mathematical sciences faculties. And I'm on the engineering and mathematical sciences team, which is why you've got me as physics students to help you out today. So we're just going to have a look at a lot of things that might help you with your literature review and scientific writing and searching for information for your dissertation or thesis, depending on what kind of postgrad student you are. Because I am aware that for some of the undergraduate physics students, you don't do really very much research and writing, and then all of a sudden in your postgrad you have quite a big piece of writing to do. So we're just going to show you how the library can help you with that and give you some tips to make sure you can find all the information that you need to write your dissertation or thesis. So if you want to boot up the PC in front of you, if you haven't already, because I will get you to do some practical searching things during the session as well. So yeah, today we're going to go through literature reviews, where to find information for your literature reviews, once you've found the right place to search, how to put together an effective search, and then once you've got your results, I'm going to explain briefly about how you can manage your results, although we don't have time to do a full class on that today. I'm also going to quickly mention about managing data if you're doing your own original research and have data, and a little bit about some of the things to keep in the back of your mind when you're writing a big piece of original research, like academic conduct, not getting in trouble, okay? And then at the end, I'm going to say, this is where you can find help. So when you guys are at the master's, postgraduate, honours, PhD, that kind of level, the way you're searching will be a little bit different. So as undergrads, you're just trying to get a general understanding of the topic, but you guys have probably got quite specific topics now in your postgrad, so you're going to need to search a little bit more differently. So in a literature review, you are trying to look at the entire body of work, the entire world of information on your topic, and find gaps in it that you might want to research and identify some of the key themes and things like that. You need to search very thoroughly for a literature review. It's not really the kind of thing you can just do a Google search on. It is quite different from the kind of searching that you may have done as an undergraduate student. So when you are searching for a literature review, here's some of the things that you might want to keep in mind. So you'll be looking at the papers in the field. So your literature review is definitely missing something. If you've missed one of the papers that's considered the most important or influential in the field, so you need to think about things like that. But when you're looking at papers that may not be the most important or influential, you also need to be thinking about where they fit into the general theme of your topic of study, which papers agree and disagree with each other, and which ones are more credible, things like that. So in terms of your own thesis, which papers support it and which papers refute it, and how much should you take into account the ones that refute it, depending on how reliable they are, things like that. So there's a lot to keep in mind while you're searching and while you're evaluating all the papers that you come across. And also, you might find that certain papers will give you ideas for methods or things you can do in your own research as well. Okay, so if we imagine this is the entire world of papers, what you want your search to do, and this is why it's important to construct a thorough search rather than just doing a quick Google, is not only identify the papers that are relevant to your topic, but also weed out the ones that aren't relevant and bring all the relevant ones together. The thing is that today with the internet, you can find pretty much everything. But the problem today is not finding things like it used to be when you couldn't just do a quick search. The problem is identifying what is good and useful and relevant for you in the massive world of information that's out there and really easy to access. So that's why we're going to talk about constructing a really good search that will actually narrow down the massive world of information out there to exactly what you're actually looking for. So there are a few different places you might want to search, and they have pros and cons. So have you guys used Google Scholar a lot when you've needed to search for things?
Yeah.
Yeah? Yeah. Cool. So Google Scholar is really easy to search, and particularly if you know exactly what you're looking for, to copy and paste a paper's title into Google Scholar really helpful. You can usually find it straight away. But the problem is that you'll get millions and millions of results and you have no way to narrow them down once you have that set of results, apart from maybe by year. You don't have much control over the set of search results, so if you haven't found what you're looking for first time, it's very difficult to make any changes to those set of search results. Also, you can't really guarantee the validity of the information necessarily. So have you guys used the library search tool OneSearch?
Yeah.
At all? Yeah. Most of you maybe not. So the difference with OneSearch is that although you can do a really quick search like Google, the information that you find through OneSearch has been curated by the library. So you're more likely to find high quality information through OneSearch because it's had a little bit of curation and selection rather than just Google Scholar, which is everything and anything. And the databases, do you guys know what I mean by databases? Have you come across?
Stuff like arxiv.org, right?
Like what, sorry?
Like arxiv?
Yep.
We're physicists, I think that's really the biggest one we use.
That's true. Okay, so but there are, Archive is like a free one, but there are subscription databases as well that the library actually pays quite a lot of money to give you guys access to. And I do strongly recommend using them. So the thing is that OneSearch can't find absolutely everything. Unfortunately, even with these expensive subscriptions that we pay to the databases, they don't allow us to index or list everything in OneSearch. So if you want to do an actually true literature review, a really thorough search for everything on your topic to make sure somebody hasn't already researched what you're searching already and it's a bit pointless you doing your topic, or to find important information that you would need to know for your topic, you do need to search in the databases. You also have a massive advantage in the databases in that you have a lot of control over your search. You can create a really precise search strategy and refine down to exactly what you're looking for. If you are using Google Scholar, I'm just going to show you a couple of tips to make it a bit easier to use as well. So what you'll notice about this reference here is that it just has these little quotation marks for the citation here. That's all it has. And it doesn't have the link to UWA. Have you guys already got the link to UWA set up for Google Scholar on your own personal PCs?
No.
Is that like a VPN?
No, it's not. Okay, I'll show you how to do that. So if you want to go to Google Scholar, I'll show you how to get that set up and make your lives a bit easier with Google Scholar. Okay. So, I've just searched for gravitational waves on Google Scholar. You can search for whatever you like, it doesn't really matter. So you see in my search results, it looks a little bit different than that screen capture that I just showed you. So there's a link called Find It at UWA. Oh, the library PCs may already have this set up in fact, but you can still have a look at where it is so that you can set it up on your own PC later. So if you go up to the menu in the top left of Google Scholar here and click on Settings, under Library Links, you can search for University of Western Australia or UWA, pretty much whatever you search will bring it up, it's okay. And then you can select it and save that as your preference. And then what happens is, when you search for results on Google Scholar, it gives you, if the library has purchased it, it gives you a direct link to that paper in OneSearch. So you'll be able to get full text of a lot more things than you used to be able to through Google Scholar if you set up this Find It at UWA link. So a lot of things that are hidden behind paywalls that you wouldn't normally have access to on the open web. As a UWA student, if you set up that Find It at UWA link, you'll be able to link straight to the full text. Another thing that you might find useful is setting up a citation link. So again, just the menu in the top left and settings. And then Bibliography Manager down the bottom here. So you guys can set it up so that it has a quick link to send all the information you need to cite a source correctly to EndNote, or to create a BibTeX reference for you if you guys use LaTeX and BibTeX. And we'll talk about EndNote and BibTeX a bit later, but just to let you know, if when I talk about that, that kind of thing does sound helpful to you, you can set up a really quick link in Google Scholar. And I'll just do that now. I'll select EndNote and click Save. And now you see Import into EndNote is a little link at the end of each reference. So now, I can really quickly get Google Scholar to send me every single piece of information I need to correctly reference this source and send it straight into my EndNote library. Makes your life a lot easier. So just something to note. Okay, so in OneSearch, it does have some advantages similar to Google Scholar in that you can do a really quick keyword search. But like I said, the collection's chosen by the library, and also in OneSearch, you can refine your search. So once you've completed your search, there are all these filters on the left-hand side that allow you to get a lot more precise about the results that you want. So that is really helpful, particularly these peer-reviewed articles. One, you can tick that box and apply it as a filter to your search, and then you can be a bit more sure that the information you've found is accurate and reliable. You guys all know what peer review is, yes?
Yeah.
Yes? Good. Okay. Just checking. As postgraduate students, you're also eligible for something called the Get It service. So if you sign into OneSearch, not only does that make sure that you have access to everything UWA subscribes to, because OneSearch knows that you're a UWA student, so it gives you access to all the extra things, but also, as a postgrad student, if there's something we don't have that you need to read in full text, you can ask us to get it for you. So if you click this expand my search up here when you're searching on OneSearch, that allows you to search for things we don't own and then request them. Would you like me to show you how that works?
Yeah.
Yeah. All right. So if you go into OneSearch, you can find it just by Googling UWA Library or UWA OneSearch, something like that. Now I'm going to sign in so that OneSearch knows who I am and knows that I have the right to have access to the Get It service, just like you guys do as well. Okay, so now that I'm signed in, I can tick this box to expand my search, and now there will be search results that UWA doesn't have access to, but which you guys can request. So let's try this one, because it didn't specifically say that we had it. Yeah, excellent. So this is something that we don't have. If you know that you really want to read this, that it will be really useful to you for your studies, under request options here, you can get it from another library. And then what that does is it already fills in a form for you with all the details of the item that you want. And all you have to say is, which library would you like to collect it at? You have to tick that even if you want a digital copy. That's just the way the system is, sorry. So just pick a random library. If you're asking for a digital copy, it doesn't matter. And just submit it. If you want something that you can't even find in our search results by clicking expand my search, you can still fill in the form manually yourself with the get it request up the top here. Type in the details of the article that you're looking for, and we can email you a PDF scan of it usually. Occasionally you can only get a physical copy, but usually we'll try to get a scan and we'll email it straight to you. Okay. Do you guys have any questions about that? So if you come across something that you desperately need for your studies that we don't have as postgrad students, you can access that. So in the databases, you'll have access to even more papers that you can't find through OneSearch. So here are some of the databases that you might find useful as physics students. So Scopus and Web of Science are general scientific databases. So not specific to physics, but very large, very comprehensive databases that you might find really useful. There's Archive, of course, that's open access. You don't need to be a UWA student to access that. It's alright, I'll send you the slides afterwards. And the Public Library of Science, again, is an open access one. But also, how many of you guys are medical physics students? Yep, cool. So Ovid might be really useful to you guys. That's a medical one. There's also the IEEE and Engineering Village. If anything you're doing in your physics degree has sort of practical relevance to engineering applications, you might find some of the engineering databases really helpful as well. So where you can find the databases that are relevant to you, including probably more that I didn't list there, is again through OneSearch. You'll see up here there's a link that says databases. So if I click on that, it loads a page for me with a whole list of topics, and you guys obviously would be under physical sciences, and then physics here. So if you click on that, that comes up with a list of databases, so there's 16 here, that are specifically useful to the physics students and which aren't all necessarily indexed in one search. So there might be things in these databases that you can't find anywhere else. So I do strongly recommend having a look at these and conducting your searches in these databases, because you will find that it gets you a lot more useful information that you didn't have access to elsewhere. So now we're going to run a search in Scopus, and I'm going to show you how to construct a search in Scopus because it's a large general database. But something important to note is that you will be able, once you've constructed a really good search using these methods that we're just about to do, the great thing is you can pretty much copy and paste it to any other database as well. Some databases will have very slightly different rules about what symbols they'll accept, but for the most part, once you've constructed a great search that's getting you exactly what you want and not getting you any irrelevant papers that you don't want, you can then run it in all the other databases. So that's why it's worthwhile spending a bit of time constructing a search. So, when you're constructing a search, obviously you want to look at your topic and pick out what the keywords are, the main concepts in your search. But then the important next step that a lot of people miss is finding synonyms for these terms, and then the next step is connecting them with what we call Boolean operators. Are you guys familiar with this at all, with Boolean operators?
Yep.
Yep? No? Okay. Cool. Got a bit of a mixed room, that's good. So the reason you might want to type in synonyms is you don't want to miss a paper just because the author happened to use a different term than the first keyword you thought of for your topic, yeah? So if you're looking for papers about cars, you don't want to miss a paper just because the author typed in vehicle or automobile as their particular title or search term in that paper. So that's why it's worth going through and thinking of synonyms for the keywords that you're searching. And then you connect them with Boolean operators to explain to the database what to do with all these synonyms that you've thought of. Since some of you are already familiar with Boolean operators, I'll go into a little bit more of even more advanced searching strategies, which are using the thesaurus and subject headings in the database and using symbols that we call truncation or wildcards. So let's just quickly cover truncation because that's a really easy one. So can you see what's happening with the education thing there? Are you guys familiar with that, with using the asterisks for searching?
Yep.
Yep, okay. Got a mixed room again, that's cool. So by putting the asterisks at the end of what we might call the trunk or the base of the word, it makes sure that we don't miss papers just because they've used a slightly different form of the word. So putting the asterisk after the T makes sure that our search finds all these other forms of the word education, because you don't want to miss a really relevant, excellent paper on your topic just because the word happens to be grammatically a little bit different. So that's why it can be really useful to pop in that asterisk into your search term. The thesaurus and subject headings are specific subject words that have been used by the database manufacturer to refer to a topic. So it can help you a bit and save you time with the keywords and synonyms. Instead of having to think of every synonym yourself, if you're searching for a topic that's quite established, the database probably already has a standard term in their thesaurus that they use to refer to that particular subject. So they might have decided that every single paper about cars, no matter if they've used the word cars, vehicle, or automobile, they have classified that as automobile. So if you use the thesaurus of the database to find out which word they have used for a topic, you can then be much more certain that you've found every paper on that topic just by searching for that subject heading, rather than having to think of every single synonym. Does that make sense? You guys following? I can show you how this actually works in a second. The only difficulty with that is that if you're searching for something quite cutting edge or new, the database makers may not yet have time to have decided on a subject heading for that topic. So just be aware, not everything will have a subject heading and it's still worth thinking of synonyms. Okay, so if we were going to search for the topic, how can we measure the accuracy of atomic clocks? And please forgive me if this topic doesn't seem very particularly good to you. I stopped doing physics in year 10 in high school. So I'm not the expert on physics here, I'm the expert on searching, so please forgive me for the topic. But if we were searching for that, what would you say the key terms, the key concepts in that topic are?
Accuracy, atomic clock.
Yep.
Precision.
Yes, correct. So we want to measure how accurate atomic clocks are. There's 3 basic concepts in that search. And so then we've got these concepts, and we need to think of some synonyms to add to them. So can you guys think of any off the top of your head? I know that can be a little bit difficult.
Observe.
Yeah, that could be one. You mean for measurement?
Yes.
Yeah. Anyone else?
Investigate.
Yeah. Observe it and investigate are, I guess, similar to measure. You might want to try them. I'm not sure they're close enough, but that's okay. Finding synonyms and especially thinking of them off the top of your head can be really difficult. I realise that. That's why it can be a good idea just to do a quick Google search of the topic to think of synonyms. That's the sort of thing that a general Google search might be helpful for. You don't have to be able to think of everything by yourself in an instant. So here are some that I thought of. I'd like to particularly point your attention to error. So sometimes antonyms can be useful in the search. For instance, there might be a paper that doesn't mention the accuracy of atomic clocks, that mentions the error rate or the error margin or something like that. So sometimes antonyms can be useful synonyms. And I wasn't sure about synonyms for atomic clock myself. These seem to be some of the common elements used in atomic clocks, but again, please forgive me if that's showing my lack of knowledge of physics. But you guys get how I've constructed this table, right? And it can be really useful to just open up Microsoft Word and construct a table yourselves for your search terms, particularly because then you have them digitally and they're really easy to copy and paste into databases. So then we need to connect them with Boolean logic. So, do you guys know what the OR operator does in Boolean logic? Yep?
Yep.
Yep. Okay. And the AND operator, you guys know what that does as well?
Yep.
Yes? Okay, excellent. So we seem to be pretty informed. I'll just go over it really quickly, just in case. So, we don't care which word is used here, as long as one of them is in the article. So that's why we use OR. Because OR means they don't both have to be there, just one of these terms has to be in that search. Same here, we don't care whether it uses the word accuracy, precision, or error. We just want to make sure that concept is in the papers that we find. But the AND term says that both of these must be in there. So running this search will make sure that something from this set, something from this set, and something from this set, it doesn't matter which one, is in each paper that we find. Does that make sense? Cool. Okay, so as I was saying, in Google, you'll get an awful lot of results. And I'm sure you guys all definitely have the time to wade through almost 1 million results, right? And similarly, in Google Scholar, 100,000 results. I'm sure you all have the time to wade through and read the abstracts of 100,000 papers. So this is why we might use one search, and might use some of the filters in one search, and now we've only got 44 results. And hopefully, because we've started to construct a search, although as you can see, in one search you can just use a simple keyword search, hopefully by using some of the filters, we've narrowed it down to much more relevant ones, and now we only have 44 abstracts to have a look through and see if we found what we want. If we run the search in Scopus, using all the key terms that we thought of and the correct Boolean operators, I didn't put the number of search results. Let's find out. So you guys can get to the database Scopus just by searching for the term Scopus in one search. So one search doesn't only find you individual articles, it also can find you the databases if you happen to know the name of a particular one that you would like. So if you type in Scopus into one search, and you'll want it up anyway because we're going to do our own searches in a moment. Right, let's run that search. Now you don't have to create an account with Scopus. It is free, and you can do it if you would like Scopus to email you the results of your search, but you don't have to do that, so you can just ignore that pop-up that just came up there. So you'll notice in Scopus, you don't have to put everything into brackets because it already creates lines for you that are connected with AND. But if the database only has one search box for you to type terms into, that's when you would use these brackets to isolate each concept. But luckily, you don't have to in Scopus because you can just add lines and they're already connected with and. Do you guys know about these quotation marks that I've used here as well? Around atomic clock? No? Some of you? Okay. So if I didn't put the quotation marks around the term atomic clock, it might find a paper that just happened to have just the word atomic anywhere in it and nothing to do with atomic clocks. Similarly, it might find a paper that was about measuring the accuracy of clocks, but not specifically atomic clocks. So by using the quotation marks, it makes sure that my search will only find documents with both of those words spelt exactly that way in that order. So that's just something useful to remember if you're searching for a concept that requires more than one word to describe the concept, then you can join it with the quotation marks to make sure your search is more accurate. Okay, so we've got an 800, so already that's an awful lot better than the million that we had in Google. And then as you'll see, just like in one search, we can narrow it down using the filters on the left-hand side. So if we only want very recent papers, we can select a few more current years. If we have a look at the subject areas and see that there are some irrelevant subject areas that we don't think would be helpful to us, we can exclude those subject areas. If we only want conference papers, which you might sometimes in a search, for example, you could select that. If for some reason you're searching for a topic where it's very important that it's about a geographical location, as you can see, there's an awful lot of ways you can filter your search in a database. So you can keep narrowing down your search like this, or, like I said, not being an expert on the topic, there might be some errors with my keywords, which maybe with a bit more refinement, we could come up with a better search in the first place that gives us less than 200 documents. But it's still an awful lot better than wading through 100,000. Oh, and also, if you need to look over anything that we talked about with searches again, I will provide the PowerPoint slides, but also we have a library guide about composing a search, which has this kind of information in it, which might be really useful to you guys as well. So that's linked there. Let's go through that. Okay, so now you guys can either search for your own topic, think of the keywords, the synonyms, and join them together with the appropriate Boolean terms if you have your own topic that you'd like to search for. Or if you can't think of one right now off the top of your head, please try one of these topics listed on the board. So you can work in 2 groups if you want, or you can work individually. That's totally up to you guys. And I'll just give you like 5 or 10 minutes to try and see who can come up with the most reasonable number of search results. So we don't want millions, but we don't want only 4, because then we're not doing a good comprehensive literature search. So pick your own topic or one of these topics, and please have a go using the skills that we've talked about and run your search in Scopus. Or if you saw one of the databases earlier that seemed more relevant to your topic, try one of those as well. You might have noticed in Scopus that automatically this drop-down menu is searching in the article title, the abstract, and the keywords. And that is a really good place to start, because obviously the author is going to explain what their paper is generally about in the abstract. That's kind of the point. So the abstract is a really good place to search, but if you're running a search and you're not finding that it's getting many results, then you might want to change this instead to search all fields. And in that way you can broaden your search even more. So now it's not just searching the title and the abstract for your search terms, it's searching absolutely every piece of information it knows about the articles for your search terms. So if you're finding your search has too few results, that's something you can try as well. And again, that's something you'll find in most databases as an option. Also, for you guys who are, specifically for you guys who are medical physics students, but just to talk about the concepts of the thesaurus generally as well. So this is Ovid, which is a medical database, and which you guys may want to search as medical physics students. So every database pretty much will have a thesaurus, and you'll find it in Ovid under Search Tools. So if I click on Search Tools here, So I'm now searching the thesaurus. I'm not searching for papers, I'm searching the set of terms that the database uses as standard, like I was explaining earlier. And I'm going to search for the term melanoma. And so what you can see here is what it's used for. So if you search for any of these terms, they will revert to the database thesaurus term, the subject heading melanoma. So there's no point you including any of these in your synonyms if you include melanoma as a subject heading. So not as a keyword, not as something you're searching for in the title, but as a subject heading that the database has applied. If you search for melanoma in the section subject heading, there's no point you including any of these in your synonyms. Similarly, if you think, I'm kind of searching for melanoma, but that's a bit too specific for what I'm searching for, in the thesaurus, you'll also find what is the broader term. So what's the next level up of explanation for melanoma? And then what are narrower terms? If you think, I'm searching for information on melanoma, but actually I'm searching for a really specific type of melanoma, the narrower terms, the smaller concepts than melanoma are also listed in the thesaurus. So medical databases are particularly strong on having a thesaurus. They use something called MESH, the medical subject headings, but other databases do use thesauri, as I hate that word, as well. So you'll find this really useful to see what subject headings specifically the database has applied to your topics. So just something to note. Okay, so we're also going to talk really quickly about citation searching. So if you guys have found a really great paper, gold star, it's amazing. You might want to think about papers that are related to it in a way to find other papers rather than continuing your search with keywords. So you might want to look at papers that have cited the same people. Yeah, so this is the reference list for your gold star amazing paper. Who else has cited the same references? Because they're probably talking about the same topic, yeah, if they're using the same research. You also want to actually read the references as well, because those papers are obviously the knowledge that this paper has built on. You want to look at what else has this author written, because obviously most people dedicate themselves to a particular subject area, so you'll probably find other works by that person very helpful. Also, who has cited them? Who has built on their work, particularly if your paper wasn't just published last month. Who has built on their work can be a really useful way to expand your search. And finally, in most databases, you can set up what's called a citation alert. So the database will email you if anyone else cites them in the future. So then you can stay updated on who else is building on that amazing paper that you found. Okay, so Web of Science and Scopus are particularly useful for this. So in Scopus, if I select a couple of the results, I can click on View Cited By, and I can look at a list of all the papers that have referenced these particular papers. In this case, it's not going to be much use as they were published this year and they have not been cited by anyone yet. But for older papers, it can be really helpful. Web of Science has the same thing. So if we're looking at these papers in Web of Science, there's actually a hyperlink over on the left-hand side here. Make it a bit bigger so you can see it. It not only tells you how many times that paper has been referenced, you can also click on the number and see what those papers were and read them. So that's a really good way to expand your search and something you should really think of doing when you're doing your literature review and looking for information. Do you guys have any questions about that? Cool. Okay. So when we have constructed our amazing search, I'm just going to quickly go through that you guys all know you have to reference, right? Yep. And do you know the two main ways that the two main varieties of referencing style that you might be required to use?
Latex and EndNote?
No, those are software tools for referencing. I'm talking about the style itself. So those are specific styles. What I'm talking about is, so this here is an author date style. So the in-text citation has the author and the date. And the reference list is usually in alphabetical order by the author's surname. There are also numerical referencing styles, where instead of putting the author and the date, you just put a tiny superscript number, and then your reference list is in numerical order by which one you cited in order. So those are the two main ways of referencing. You guys, might use Harvard, which is an author date style, or might use Vancouver, which is a numbered style and is most commonly used in the medical profession, so I think that's why medical physics students might use it. And we have really comprehensive library guides on these styles, so there's links to those there. So it explains to you how to construct a reference on basically anything, so a journal article, a book, a website, they're all constructed differently, and we have examples for all of them. And also librarians can help you with any questions you have about referencing. You can come along to a drop-in session called Write Smart, if you like. It's run at Reed Library from 10 a.m. to 12, Monday to Friday. If you have referencing questions, it's really good to bring those to Write Smart, but you can ask us at any time as well. So, referencing is really, really essential, but particularly if you guys are writing postgraduate kind of length documents, you're going to have an awful lot of references. So you're probably going to want to manage them in some way. And EndNote is some software that can be really helpful for that. We don't have time today to go through all the functions of EndNote, but the library does run 45-minute classes on EndNote, and you can sign up to one from our EndNote guide. And I would really, really recommend using something like EndNote to organize your references. Just makes your life a lot easier, and it also means you don't have to manually type out your references. So basically, when you're searching in databases like Scopus, somewhere in the database there will be a link that says something like save, export citation, cite, or it might even just say EndNote, and that's where you can get that information from that database, take it straight into your EndNote program, and then from there you can export the reference perfectly formatted for you, assuming the data that you downloaded was accurate. So please do come along to an EndNote class. It will save you a lot of time, make your life a lot easier. You can organize all your references into groups in EndNote as well. You can even create smart groups from the keywords of your references, make EndNote organize the references for you based on the keywords in the references, which again makes your life an awful lot easier when you're trying to look back through and find your references. Although, for you guys, I am aware you probably write with LaTeX rather than with Microsoft Word. Yeah? Yeah. And EndNote is made primarily for integration with Microsoft Word. So, what I would say to you guys is EndNote will be really, really useful to you for gathering and organizing your references, and I do still recommend to use it because EndNote can export to BibTeX format, which is the coding for a citation that LaTeX can read. But as far as I understand, a BibTeX document is just a text document that has a list of all your references. So you can export that from EndNote, and then it will have this kind of information about the author, the title, the year, all that information that you've gotten. And then you can insert it in LaTeX. You tell LaTeX what style, what referencing style you want to use. You tell it to use your BibTeX file, and then it will format the references for you correctly when you format and run the document. So this is what it might look like when you have a LaTeX document marked up with BibTeX citations. So we are using APA citation here. You can see there's a few document references that have been inserted, and you can see it's been instructed to format the bibliography at the end in APA format. So yes, like I said, I don't use LaTeX myself, so I can't go into the absolute specifics of it, but I hope this makes sense to you guys as using LaTeX, how you can get all your references into EndNote and organize them, and then to get them perfectly cited in the correct format in your LaTeX document, you just export the whole list of references from your EndNote library into the BibTeX format, and you can insert them into your LaTeX document. I hope that makes sense. Is that okay? Is that helpful?
Yep.
Yep. Okay, cool. We also have a whole web page of the library about managing your research data. So if your postgraduate research is creating a whole load of data, the university does have some policies about it, and also it will just be really helpful to you to manage your data properly. So there's a whole toolkit here which I've linked the website for you to help you with that if you need it. And also we're quickly going to talk about academic conduct. So the whole point of referencing is to show that you're not stealing anyone's ideas. So please don't. Please reference everything correctly. You will get in a lot of trouble at UWA if you don't reference correctly. And we have a module called ACE, which you've probably all done. But if you haven't, that has the rules about academic conduct, so you might want to take another look at it. It is on the open web. Referencing is not just taken seriously at UWA, it's taken seriously outside of UWA and if you move into professional academia as well. So this is a website called Retraction Watch, which lists the people who have had to retract their papers the most times. So as you can see, this person at the top of the list here has written 183 papers which they had to retract because of plagiarism. So, you don't want to end up on this leaderboard. You don't want to put the effort into writing 183 papers only to get in trouble and have to retract them and have a terrible reputation and be on Retraction Watch. So there is a point to learning how to reference correctly, using EndNote and all that stuff here while you're students, especially if you want to move into academia. So just to mention that, it's quite interesting that people would plagiarise that much. But anyway. And we do also have a system called SafeAssign. If you haven't done many written assignments before, you may not have had to submit them through a text matching tool before. But SafeAssign is one that UWA uses, and we sometimes also use one called Turnitin as well. Are you guys familiar with text matching software at all?
Can we download it? Is it for us?
No. So this is through the LMS. So when you submit your assignment through the LMS, you'll be submitting it through the SafeAssign or Turnitin link, and it will just check if the text in your assignment is matched anywhere else. So you wouldn't want this much text in your assignment to have come from somewhere else. But if a small amount is highlighted, as long as you have referenced it, that's probably okay. If there's a couple of words highlighted or something like that, then if you've referenced it correctly, you're probably not plagiarizing it. It's the sort of thing that there's no really hard and fast rules on, but you do want the percentage of your assignment that's matched to be as low as possible. If your tutor has set it up, they might allow you a practice submission attempt, but usually that's up to your lecturer or unit coordinator. Also, there's a whole load of workshops on scientific writing. If you haven't done a whole load of scientific writing before and you need help with your literature review and how to write it, StudySmarter do a whole load of workshops, and there's also these online things about academic writing that you might find really useful as well. So all linked in the PowerPoint for you, and you might want to come along to these workshops that are coming up in the next couple of weeks if you haven't done a whole load of scientific writing before. So I hope we have covered all this stuff in this session. Do you guys have any further questions? You are very, very welcome to ask me or another librarian. That's what we're here for. We're here to help you. Our email address is on the slide for you, and you're always welcome to email or just come into the library. That's totally fine.